Monica. Okay. Let me see if.
Keshav garu.
Yep.
Yeah, actually, I'm thinking to do some question.
You can do that. I would suggest wait for just this week. Okay.
Okay.
So my suggestion is you do these things with understanding this time. So then you start on this weekend. I would suggest
Okay.
to. I will actually suggest there are two quests you should start doing, because if you do the quests, advantage is you can do the certification also later on.
Okay.
Okay. So you'll get the
Yeah.
credits.
Yeah, then and actually choosanu. So I just want to know, is there any particular way to go on with them?
No, there is nothing special. If you get onto the quest, maybe you can actually start with, if you have time, right, during the day, you
Yeah.
can actually start with the big data basic one, big data analytics
Okay.
basic one. There are two quests, one for basic and one for advanced.
Yeah, big data on AWS
On
and big
AWS,
data.
yeah. So you can
Yeah.
start with the basic one. A lot of that stuff already you will know from the concepts wise. So
Yeah,
if you
చూసానండి మనం చేసిన ల్యాబ్స్ కొన్ని.
కొన్ని ఉంటాయి, కొన్ని
Yeah.
something different ఉన్నా కూడా you can actually just start doing those things, because there is nothing wrong. You will do more things. It's good actually. But by doing the quest, you'll gain some credits. So that way,
Okay.
I mean, when you go for certification, they look for like what quests you've completed so far, and you know
Okay.
allow for the certification test exams also.
Okay.
Okay, I would definitely suggest after this course to do
Okay.
that big data analytics on AWS basic and advanced, both questions completion as an additional exercise. I thought of telling
Okay.
that end of this week. I mean,
Okay.
but you could do, you can start with the basic one for now if you have more time. But
Yeah. Okay.
because right now you may have stuck with the time, right? So if you are doing this exercise, so I don't want to have
Yeah.
a time crunch.
Okay. Thanks.
Okay, yeah, no problem. Yeah. Okay, I think we have Durga, Kishore, Monica, Balu, Dheeras. Okay, so I think we are already past 10 minutes, so not sure if others joining or not, but I'll get started. Okay, so as we start with yesterday, so yesterday there are two labs we were trying to do. I believe most of you finished one, and the second one is still in progress, maybe for some. And if you're already done, that's good. But otherwise, also like today, also like we'll spend more time on the lab only. So today's lab will be more of a Redshift specific exercise. And we could actually do even something missing yesterday also, you can still cover up, because today is I'll try to put more time left for the labs only, because this is where you get some time. But tomorrow again there will be a lot of time I need to introduce the machine learning concepts and other things, so you'll have less time for lab tomorrow. So today you'll get more time, so try to finish everything that is anything lagging from yesterday or today or whatever. So because today is only one lab, so anything lagging from yesterday you can cover that today itself. Okay, and with that I will just take like maybe 10 minutes to just give a quick introduction about the Amazon Redshift and its background, so that you know what you're learning and why you're learning. when you start doing the labs. Okay, so this is where I mean, we already, if you remember yesterday itself, we already used some extent of Redshift in one of the exercise, but even without knowing what exactly Amazon Redshift is. Okay, but within the Amazon ecosystem, Redshift is one of the important component. It's basically to give a quick background on what this means, right? Generally, the big data platforms we're talking about are more meant for structured and unstructured data stores, right? So, for example, HDFS file system, it can store both structured and unstructured data. S3 storage, it can store both structured and unstructured data, right? So, NoSQL databases. So, you have various type of data stores, but Amazon Redshift is also one of the type of data store, which is also a columnar storage, something similar to NoSQL database, but this is only meant for structured data store. Okay, and the biggest difference is, if you take a NoSQL database, it is not really meant for like a data warehouse type of database. It is meant for transactional purpose with low latency, quick transactions, and small data sets. It could be both structured or unstructured. But when it comes to Amazon Redshift, it is more like a data warehouse type of database, something similar to Netezza or Teradata. If you know of, not even those actually. Those are not columnar storage. They are regular storages. But now they are also like latest versions, Netezza and all that. They are also coming to columnar storage model. And HP Vertica is one of the columnar storage model. So there are a lot of similar things, but Amazon Redshift is like one of uh, the petabyte scale database, which is meant for data warehousing purpose. So when you like, it's mainly columnar storage, and it's mainly like massively parallel processing, MPP. That's why I compared with Netezza and Teradata. They're called MPP databases, massively parallel processing databases. So this has the similar architecture to parallelize the distributed SQL operations. Okay, it runs very complex queries and analytics against structured data using SQL. So a lot of analytic stuff can be done using this SQL, but it's all against structured data. And you'll learn more about this, but again, very quickly, why, when you have like a Hadoop environment, Amazon EMR, S3 storage, so many things are there, and why you still need Amazon Redshift like a data warehouse, even on Amazon platform, why you still need a data warehouse platform. So remember, just because we have Hadoop, or just because we have all these new technologies available now for big data or structured or unstructured data sets, the old concept of data warehousing still don't go anywhere. Okay, as I explained initially in the architecture slides very originally, data warehouse is always there, and it will be there in the future also, even with all this new technology coming into picture, like a real-time data lake, Hadoop data lakes. The reason for that, data lake is not really replacing the data warehouse. Data warehouse still there as part of any organization data storage and organizing point of view. But the Hadoop platforms are helping as an in-between. Before you finalize your data and do all your data integrations and do the data quality checks and everything, and finally once you feel good about your data and completely transformed and make it available for regular reporting and dashboarding and all that, that a lot of general BI functionality still goes through the Redshift or any other data warehouse. But intermediate step, extract, load, transform, right? So to load the data into somewhere, we are using the Hadoop environment or any S3 or any of such storages. Because without knowing what this data is, structured or unstructured, whatever is the raw data, we just want to quickly load it. But once we know what is this data, then in that place we wanted to do a lot of data, real-time data analytics, or without much transformation, you still want to use the data for some analysis and data science and data discovery to figure out what is there in the data. And once you know what is there in the data, then you will make some relationships to the data and make it more meaningful with some structured data model. You create some the data model as part of the data warehouse setup, and let the data move into the Redshift for the data warehousing purpose, because which is supposed to be meant for um, summarized data sets for the reporting purpose. Still, you still need to have those type of setup. Okay, so there is nothing changing. That's why still data warehouse is there, but still because we are depending on Amazon ecosystem here, so everything is being Amazon, like Amazon EMR, Amazon S3, Amazon DynamoDB, or Amazon Firehose, Kinesis Firehose, Kinesis Streams. With all the things that we are doing, you know, if you do everything here, and then finally you want to move all your data from Amazon platform into some other data warehouse on your local on-premise infrastructure, for example Netija, something in my organization, right? If you want to move all this data back to again your Netija or some other data warehouse database, any MPP database you already might have, it may be a lot of expense because you're moving a lot of data again back from AWS to your on-premise. So for that reason, a lot of people are moving, uh, you know, replacing their existing data warehouse setup on-premise and creating their new data warehouse setup in Redshift on Amazon directly, because everything is anyway in Amazon, and this also will be in Amazon. And obviously the storage is cheaper on Amazon. So even for regular data warehouse, if you maintain on-premise, it's anyway expensive. So Redshift is giving that advantage. So this is a typical setup for how Amazon Redshift or any, it is a similar setup. Any data warehouse can be used like this. In case of here Amazon Redshift, let's say you have some Oracle database as your data warehouse database, still you will do the same thing, right? Your BI tools come through the network, through the internet gateway, and there may be like your Amazon S3 buckets and other things on the VPC, and you might have your Redshift or Oracle, whatever this your data warehouse is, you will still have here in your AWS cloud, and you will have a Amazon EC2 instance as a client for the administrators to run the batch jobs and things like that. Okay, so this is a typical setup. Just if you have only Redshift, for example, you don't care about any of Amazon EMR or Hadoop environment or anything. If you simply set up your Amazon Redshift is like this, but that's not the standard setup, right? I mean, this is only from the Redshift point of view, but in your entire architecture, there is a cycle, right? So first you may start with your source, and you bring the data through Kinesis streams and go through the Firehose, and then maybe you do Kinesis analytics, and then maybe you do send it to your Spark, Elasticsearch, and then maybe you send some of the data into S3, and then you might put the data into the DynamoDB, and you might transform more data, and finally you put the data into Redshift. So your architecture could be end to end, could be totally different. Okay, but in this case we are only focusing on Redshift. That's why you see the diagram like this. So this is what the high level architecture here, and this will have any big BI tool or SQL client, right, which can connect with JDBC or ODBC, can connect to Amazon Redshift, and which will connect to basically leader node. The leader node is going to be the SQL endpoint basically for any connection like ODBC, JDBC connections, and which will have the store, which will basically have metadata. Leader node maintains the metadata, and also it coordinates the query execution. And when you submit a query through any SQL client or BI tool, Tableau, ClickView, or any such BI tool, the query goes through the JDBC or ODBC, and it coordinates the query execution from leader node, and then it will distribute it to compute nodes. So compute nodes is the place where actually the data is stored. It's like really very much like a HDFS file system setup. So that is the main difference. Redshift is not it's very different from regular data warehouse databases. All other regular data warehouse databases may not have this type of architecture, but Amazon Redshift is built on columnar storage model and very similar to like Hadoop architecture. Okay, but the biggest advantage of Amazon Redshift compared to any other data warehouses, it could leverage any storage system behind the scene. These compute nodes could be taking data from S3, or it could be from Amazon MapReduce, which is EMR, and it could be from DynamoDB, or it could be from SSH regular any other um, server like EC2 instance or any files. So it can actually connect to anything basically. Okay, I mean the storage, your storage, your data storage could be anywhere, literally, and the compute node can use that as your storage, anything underlying, and it can execute the queries in parallel, and it can load, backup, restore through S3. Okay, and it can load from DynamoDB or any of these other things that I mentioned. So, and the other thing is there are two platforms that are optimized for data processing, and they're like ready-made configuration. When you set up your Amazon Redshift, whenever you spin off, so you have two options like DS2 and DC1. DS2 is going with a hard disk. Actually, it's like HDD. The other one is solid state disk. So one is meant for more of like a, from 2 terabytes to petabytes. Okay, which is a higher. It's optimized for more storage basically. And the second one is more like a smaller version, which will go from 160 gig to 356 terabytes. So it depends on your needs. You may go up to, you can spin off a DC1 type of cluster, or you can do DS2. So it depends on what you need. This is like a physical hardware platform. The difference here, you don't really spin off like cluster like a HDFS cluster here. This is like a one physical box, you will feel like, but behind the scene it will maintain, within that big box it will maintain later node, computer nodes, like that, the architecture. It's not going to be like multiple EC2 instances like clusters. Okay, it's like one big box. Even Netezza, Teradata, all that, if you see, they're like one big box. Okay, with specific sizes like this, from terabytes to petabytes. They're also like huge. But whenever you need to extend, it is like you need to extend. Suppose you buy, for example, DS2, one DS2, right? Then your data limits size crossing the limits of 2 petabytes, then it's becoming 3 petabytes. Then you don't have a choice of getting a smaller version. You have to get another DS2 because you need to accommodate one more petabyte. So, but whereas in regular HDFS systems or Hadoop systems, you don't need to bring like one big block of storage. Okay, that is the difference between the MPP databases and the Hadoop systems. Okay, but this is how, that's why these are expensive. Redshift or Netezza or Teradata, any of such MPP databases are very expensive because they have like a big machines which can hold a lot of storage and a lot of processing capacity and CPU, memory, everything. It's like a all-in-one. It doesn't have a separate operating system. You don't need to have like Linux or Unix installed on this. Redshift has its own operating system. It has its own storage capacity. It has its own, everything is like one big box on cloud. Okay. So that's the basic system architecture there. And just to go little deep into that same on the architecture side, so how the ODBC JDBC connection comes through the leader node, and when it goes to compute node, within each compute node there will be slices. Okay, the slices. This is how the rack. I mean, some people call racks, but these racks are slices. Whatever you say, when you need to add more, the slices can be added. At the slices level, you can add, but not like every 1 gig or 2 gig like that. The slice itself will be like a bigger one, so you can add multiple slices, and the compute node actually distribute the process through each slice. So this will give you much more clear clarity. Like if you see the IO disk management in the bottom. So how the IO disk management happens, basically the on top of it, if you come from the top, right? So let's say your JDBC, ODBC client, whatever it is, it could be Tableau, ClickView, whatever client, or it could be some SQL client. It is giving you some query, and that is going through the listener, which is a communication layer, and then it is actually submitting to later node. And also there is execution engine here, which will parse the query and break it into like various queries and joins. And also there will be some non-query commands. And then execution planner and optimizer is going to generate the required code behind the scene how it should work. And then it will send it to queue, and there is a workload manager that will schedule. Generally it will be you can also schedule, but generally it is like when I say schedule, it is scheduling at that time, right? And the communication layer, that's where it actually use the interconnect, the internal networking layer, and from there it will go to compute node. The compute node also will have a communication layer, and which will dispatch that piece of work, whatever comes to that node, and then that is where the query processor per slice will happen in a distributed mode. And in each slice it will have IO interaction with the disks. So this is all one section. And there is also like other than the later node and execution engine, the core components, there are some miscellaneous services and functions also available that will be used when we submit a query. Behind the scene, all these things happens. Okay, a lot of miscellaneous things also will happen. Suppose data load, unload, and system manager, vacuum defragmentation, utility functions, system tables, resource manager, compression, backup and restore, encryption, failover, query result aggregator, disk subsystem. So a lot of this stuff is like more of a administrative stuff, administrative tasks that can be done. Who is managing Amazon Redshift as their data warehouse? So a lot of this stuff happens as part of administrative or maintenance activities, in addition to the regular the query itself. Okay, is this clear for everyone? Okay, so that's it. Yeah, so yeah, as I told, like I don't have that many slides on Redshift to explain. An architecture itself, I just wanted to walk through and make sure you all are clear about how it works. But now, again, how you use Redshift for you as a user or a developer, you will never really need to know how Redshift is working. But the reason I am showing all these architecture side of things, some of them, if you know the basics of architecture, how it is working, so then you will be able to help fine tuning your queries accordingly. Suppose if you know this works in a parallel distributed mode, then when you run your query, I mean you know basically you can do some level of optimization for your queries that can work better for the parallel mode. Okay, so generally a lot of people may not care that much because they simply write some queries and execute it. System will take care how it works. But if somebody asks you how Redshift is working, how it is different from other MPP databases or other regular databases for any data warehouse, then you should have answers for that. Okay, all right, so with that I will leave it there, and then I'll come back to the exercise that we need to do today. But again, before you start today's exercise, I would suggest to finish the previous day, the yesterday's exercise, the labs, two of them, Amazon Kinesis Firehose introduction and introduction to AWS IoT, and then do this. If you haven't finished yesterday, please take time to do this today, because today is the time you want to catch up any labs that you haven't done. I just want to make sure you finish that, because you have at least 1.5 hour time today.
Sir, to do the introduction.
Hello?
Sir, to do the introduction to Amazon Kinesis Firehouse Lab, we have to do the introduction to Amazon Redshift anyway. So Do we have to like do this first and then do that?
No, either way, it doesn't matter. Without even knowing Redshift, also you could do that.
Okay.
Because there you are not really, whatever you are doing in this Redshift is a little more specific to Redshift and little deep. But the yesterday one is in the context of Kinesis Firehose. So the end target is Redshift. So yeah, I mean, again, there is no sequence required here, but I just want to make sure the labs from yesterday and today are both are completed by today, end of today. Okay, or at least tomorrow before tomorrow class starts, because tomorrow onwards we are going to tomorrow I need more time for there is a lot of new terminology and new theory that a lot you need to learn about machine learning and all. So we need to spend quite a bit of time there. So I will take more time on theory tomorrow, uh, but we'll do some lab also on machine learning. But I wanted to finish today so that we can get into the different topics, completely new type of topics. Okay. So having said that, let me put this exercise. Okay. So I will also start in parallel, okay? Because I haven't catch up yesterday. So I will also, I mean, you can do in parallel. There's nothing you can do, but I mean, you don't need to wait for me, but you can continue. I just wanted to finish mine also in parallel, so that if any of you have any questions, I can clarify them. But one question came in the morning when the Balu told me is he didn't see the EC2 instance because I think it's an exception for him because he's working from India. So the EC2 instance that is coming up in that region, um, and the service may not be available. So if any of you in US have this problem, let me know. But otherwise, there should not be any issue from US region at least. Okay, so let me do my work here. So basically, just to reiterate, I want to finish the one that I already shared to you today, and yesterday labs. Happened. The chart is not happening. Okay, yeah. Okay, you continue on your side, and I'll continue my side, and then we'll catch up in between now if any issues or questions. Okay.
Hello? Hello?